Let me show you how to do some proportional reasoning questions real quick with Coulomb's law. So Coulomb's law looks like this. The force electric between two charges is Coulomb's constant times charge 1 times charge 2 divided by the distance between those two charges squared. So in proportional reasoning, that's one of those types of questions where if you double this, what happens to the force? If you double this charge, what happens to the force? So one thing in proportional reasoning is we don't need to worry about constants. We write the proportional symbol like this little fish. So since we don't need to worry about constants, actually in this video we're not going to worry about Coulomb's constant there at all. And we just say the force is proportional to charge 1 times charge 2 divided by the distance between them squared. So whatever you do to charge 1, that's what you do to the force. Whatever you do to charge 2, that's what you do to the force. Whatever you do to the distance, that gets squared and you divide that. And that's what happens to the force there. So let's do a few examples here. Let's say we have a charge here, we'll call it charge Q. We have another charge here, we'll call it Q, and we'll say the distance between the two is D. And let's say the force between those charges, whether it's attraction or repulsive, it doesn't even really matter right now, is F. What if we changed one of these charges? What if we change that charge to 2Q? Well, whatever you do to charge 1, that's what you do to the force. So since you doubled charge 1, let's call it, we would double the force there. If instead we had said like, oh no, we're going to triple this one. It's going to be 3 times the charge. Well, then it would be 3 times the force there. Let's ignore that. It also works the other way. Let's go back to, let's just say it's charge and charge separated by D. What if we cut this force to 1/2 of what it was before? Again, whatever you do to one of the charges, that's what you do to the force. So the force would now be 1/2 of what it was before. All right, what if we double both charges? Let's say we have Q over here, separated by a distance D, and we have Q over here, and let's say the force between those is F. So what if we doubled this charge and double that charge? Well, doubling this one will cause the force to double to 2F, but this will also cause it to double. So we'll double the 2F and we'll get to 4F there. A way to sort of look at it is take this equation up here. You can ignore anything that you're not changing. So in this case, we're not changing the distance, so we'll just say force is proportional to charge 1 times charge 2. And then we plug in for these two charges what we are doing to them. So since we doubled charge 1, we'll put a 2 in for that, and we doubled charge 2, so we'll put a 2 in for that. 2 times 2 is 4, so we should have 4 times the force. So if we use that logic over here, again, real quick, let's say that we had tripled instead of one of our charges, made it 3Q, and we had made this one 4 times bigger. So using the same logic here, we'd say that the force is proportional to charge 1, we tripled, charge 2, we quadrupled, and so we'd plug that in. 3 times 4 is 12. We would have made the force 12 times bigger than it was before. All right, let's look at changing the distance between the charges. So if instead we change the distance, let's look at that. Let's say we got charge Q here, separated by distance D, and another charge Q here. Whoops, sorry, that's really messy. Remember this whole time that force is proportional to, if we just focus on the distance, it's 1 over the distance squared. So let's say we change this now, and Q is now moved out to 2 times the distance here. So let's plug that in here. Force is proportional to 1 over, we're going to change the distance to what we did to it, a 2. Don't forget though that it's squared. So that becomes 1 over 2 squared is 4. So we're now at 1/4. So if this force was just called F, the force between them when we doubled the distance would only be 1/4 of F. If instead, then I think you can see pretty quickly, we move the distance out to 3 times the distance, Once again, force is proportional to 1 over the distance squared. So we'll triple the distance, but we'll square it. So we would have 1/9 the force. So tripling the distance cuts it to 1/9. So if you quadrupled the distance, it would be 1/16. If you quintupled the distance, it would be 1/25. So lastly, one more before we get into changing two things at once. Let's say we cut the distance smaller. Let's say we have Q, some distance D, and Q, and we'll say that that force is F. What if we did this? We took Q and we cut the distance to 1/2 the distance. We move them in closer. You should realize just logically that they'll exert a stronger force on each other if they're closer. So let's plug it into the equation. 1 over the distance is now 1/2, and we'll square that. So 1/2 squared is 1/4. But we're dividing by a fourth. Whenever you divide by a fraction, you multiply by its reciprocal. So dividing by a fourth is the same thing as multiplying by 4. So if we cut the distance to 1/2 of what it was before, and this was F, this will now become 4F. So hopefully you can see that if you cut the distance to 1/3, then you would actually get 9 times the force there in that case. So last thing is, let's change all three variables just to practice it. Let's say we have charge Q separated by distance D, and then we have, another charge over here. We'll call it Q, and the force between those is F. Let's say now that this becomes 2Q over here, and the distance becomes 2D, not drawn to scale, and then this charge becomes 4 times the original charge. So charge 1, we doubled the charge on it. Charge 2, we quadrupled the charge on it. It's 4 times bigger, and the distance we doubled. So we follow the same pattern, and this time we're going to plug in for each one of these. So charge 1, we doubled. Charge 2, we quadrupled. The distance we doubled, but don't forget to square it. So 2 times 4 is 8. 2 squared is 4. And 8 divided by 4 is 2. So that means overall, if this force was F, and we did all of these things, double that, quadruple that, double the distance, we wind up with 2 times the force.